All right, U2A2. I'm going to do this in red. It's Valentine's Day right now when I'm filming this, so that is exciting, as you can tell by the excitement in my voice. So here we go in red, and we're talking about summation notation. So summation notation, if you did grade 11 functions, the university prep, you may have seen series and sequences. You should have seen that. Grade 11 mixed level math, you probably didn't see that. It doesn't really matter if you have or not, because we'll teach you everything you need to know with summation notation. So summation notation is a way to write, and it rhymes nicely, which is nice, but it's a way to write a bunch of expressions, and then we add them up together. Okay, so that didn't really come out clearly, but you'll see what I'm talking about in a second. Now, we use the upper case sigma to represent this. Now, a little bit of Greek for you. There are 24 letters in the Greek alphabet, alpha all the way to omega, which is also looks like a W almost. Uppercase and lowercase for each of them. There's your beta, which looks like a B, and your lowercase vita or beta. And then you get to sigma, which is uppercase that, lowercase that, and also a third version, lowercase that. So if you have a Greek word, why are the two lowercase? Well, this is a ending lowercase, and this is the middle of the word lowercase. So if I had a word that had an S in it, and then later on it had an S in the middle, and then at the end it had another S, you would have the uppercase, as long as it was a proper noun, and then a middle lowercase, and then at the end you would have just a plain old S, or kind of an elongated S as the third sigma. Okay, but we don't really care. We just care about the capital one for summation notation. So this is the index. K is going to be your index. We call that. So we just use a random letter, and we go from the lower boundary to the upper boundary, or the lower limit to the upper limit. So that's all confusing. Let's just use an example, and let's actually use an easier example than the one they show you. So let's get rid of this. We'll just do this. We'll rewrite this like this: 4k equals 1k squared. Okay, and we're going to look in a second here. K is completely arbitrary, but this is saying, hey, look, here's an expression. I'm going to start with 1, and I'm going to end up with 4. I'm going to sub all these numbers in, 1, 2, 3, 4, go up by positive integers, and we're going to find out what k squared is in each case, and then we're going to add them together. So it's saying start at 1, and then this says take my 1, and then do this to it. This is my function. So what I'm doing is just squaring. Okay, so 1 squared. Now I go up to the next number, 2 squared, and then I go to the next number, 3 squared, and then I go to the next number, 4 squared. And I stop there because this says this is my upper limit, and I only want the numbers from 1 to 4, and then throw this expression. So 1 squared, 2 squared, 3 squared, 4 squared, what are they? That's 1, that's 4, that's 9, that's 16. Add those together, that's 5, and 9 is 14 plus 16 is 30. Okay, so that's it. Okay, all this is saying is, can you add up, could you please add these values of this expression from 1 to 4? Okay, that's summation, the sum. Okay, and what they did here, you can look at their example here. They did the same thing, but they used a more complicated expression here. So it's k squared times k minus 3. So not only did they put the 1 here, but they put it here, and the 2 here, and the 2 here, 3 here, 3 here, 4 here, 4 here. But then you add them all up. Okay, so that's about it. Okay, the next page just says there's nothing special about the letter k. Okay, it's just like when we did function notation, we had f at x, we had g at x, you might have had f at 2 at x or whatever. Okay, you have all these different versions in functions class. They don't really mean anything. Same with this. We tend to use middle of the alphabet letters for some reason. Okay, you tend to see k and n used the most often, so this one or this one, but it doesn't really matter. I could use g if I wanted to. So I could say, look, give me this expression here from 1 to 10 and tell me what g squared 3 minus g is, and then you would go all the way through and go, okay, well the first one is 1 squared 3 minus 1, and then I'd go 2 squared 3 minus 2, and I'd work all these out and I'd add them up at the end. Okay, other things you want to look at is properties of summation notation, so some general properties. So if there's a constant, you can factor it out. So for example, if I said to you, tell me what 3x squared is between, I'll make it really easy, we'll use x equals 1 to 2, so just a real easy one, that's an x. So I want 3 1 squared plus 3 2 squared. Okay, so that's going to be what? 3 times 1 plus 3 times 4, and that's going to be 3, and that's going to be 12, and that's going to be a total of 15. Well, what I could have done is, because each of these is multiplied by 3, I could have rewritten this, factored this out as 3 1 squared plus 2 squared. Okay, and instead of doing it here, I could common factor at the start. So I could rewrite this guy, and I'll just do it over here. I could over here, sorry. I can rewrite that. Oh, my pen got stuck. As, all right, let me clean that up. Little pen issues. All right. I can rewrite that as 3 times this summation notation. So go ahead and tell me what x squared is from 1 to 2 and then multiply it by 3. So what that would be is 3 times 1 squared plus 2 squared, which is exactly what I have above. Okay, and then you work that out and you get 15. Okay, so that's 1 and 4 is 5 and times 3. The other thing is that if you have a binomial or with two terms being added or subtracted, you can break that up. So for example, if I had this sigma, let's keep it simple, x squared plus x, okay, and I went from x equals 1 to, again, we'll just go to 2, just as an example. What that is saying is if I work that out, that would be 1 squared plus 1, and then that would be plus 2 squared plus 2, which is 2, 1 plus 1, okay? 4 plus 2 is 6, and that's 8. I could have said, tell me what this is. Okay, I could break this up because they're adding in between these two. I could break these up and add them up, do them separately and add them up. Okay, so you're going to see it's the exact same thing. And what you'll see is this guy here is 1 squared plus 2 squared. And then what I'll do is I'll add to that this whole thing, which is just going to be 1 plus 2. And then that's 1 plus 2 squared. That's 5. And that's 3. And then the whole thing turns out to be 8. Okay, so you can break it down that way. You can also break it down. Just imagine if this was a negative, then this would be subtract. And then, sorry, this would still be plus here. But you would have a negative here and a negative here. So you can break this down if it's subtraction between the two terms also, okay? Another thing, you won't have to memorize that. That'll be given to you. Also, this, you can factor things out. Sorry, these are common sum notations, not factoring out. But this one here is a bit ridiculous. This is just saying if I want to add a term a certain amount of times, what's the total? So this says this. So this is kind of weird. So if I want that like this, k is equal to 3 and or sorry 1. I start with 1. I'm sorry, and I go to 3, and I just have a constant here. So if I look at this and I go, okay, what's going on here? That's a 1. And I go, how do I sub in a k in here? Like, how do I do this? Right? What are my terms? Well, my first term is just 5, and then my second term is 5, and my third term is 5. So this is a bit ridiculous, but this is saying just give me 5 and add it to itself. Have it 3 times, so that's 15. What this is saying is that's the same as 3 times 5. Okay, so a bit ridiculous here. This one here, a little bit better. I want to add up the first n terms. Okay, a way to do that is, so if I want to add up 1, 2, 3, and let's stop at 4. Let's pretend I was doing that. That is this 1 to 4, and I'm just adding up the term itself. K equals 1, and just k. So that's the same as saying 1 plus 2 plus 3 plus 4, and that's 10. Well, this expression here can also give me that same answer. So that's n plus 1. So that's your upper limit divided by 2. So that's 4. 4 plus 1 is 5 divided by 2, and that's also 10. So that equation here is the same as that summation notation there. And if you look at the squareds, you come up with this equation. If we went through it, we'd come up with this equation. If we looked at the cubes, you come up with this equation. So you don't need to memorize them. They're just quicker ways to do that. And it's kind of a maybe a more common, all three of these here are more common sums that you might want to work out. Okay, so that's about it. And if you have any questions, please send me an email. Take care.